All right, let's talk about the cubic function. This is what you should have gotten when you had your a set to 1 and h and k both set to 0. This is called the cubic graph or cubic function. It's given by the equation y equals x cubed. Our domain and range. So there are no values for x that we can't use as inputs. So my domain is all real numbers, which we write as negative infinity to infinity. And then my range will be the same thing. Any x-intercepts we have are at 0, 0. Our y-intercept then is also at 0, 0. And then are there any interesting properties? This has reflection across the origin. It's an interesting type of graph that we call an odd graph. We're not really going to get into that this year, but next year you'll hear more about that. So we could just say it reflects across the origin. And these will continue on. Both of the ends of the graph do continue on. If you didn't realize that, this is going to go on, even though on Desmos it's not really clear unless you zoom in and out. Our vertex here is at 0, 0. This is what we're actually going to call our HK. So when we talk about a vertex of the cubic function, that's the point 0, 0. A lot of times you'll hear us recall to those as locator points. So I'm going to say locator point / vertex is at 0, 0. All right, that should be good. If you wanted to get more into like the movements from zeros we've talked about with the quadratic function, you could do that as well. Knowing the basic shape will help, but this is kind of just our quick investigation of the cubic function.